Welcome. Today's class is, today's class, Engineering Mechanics class number 65. That is, starting from beginning, part 1, part 2, part 3, part 4 means in the parts, lecture number will change. But this number will keep on increasing till it touches 300, 400. Okay. We are in part 2. See, today's class is lecture number 24. Now, distributed load, final explanation. Someone will tell, it is already told repeatedly from past 2 classes. Why is telling again and again? I tell in stages. Slowly you should get the grip. So my purpose is to see that once these all classes are over, in future there is no difficulty for everybody, those who learn from me regarding distributed load or point load simple, how to find the magnitude, how to find direction, not finding direction is clear, how to locate line of action, how to find moment about any point will come. Now, once again I will tell, last time I told warning, once again go through Engineering Mechanics class 63, not previous class, previous to previous or lecture number 22. See, part 2 is equilibrium, types of loads. This part 2 is not this part 2. This I will tell you it later. Don't see here now. That part 2 is separate. This is main part 2. Equilibrium, types of loads and support reactions, lecture 22. From 1418. This I told in yesterday's class as an advice come warning. I told something there. From 1418 onwards. In class EM, class 63, lecture number 22. I will just tell once. I need not tell it. In case of distributed load, let it be UDL or UVL, either represented by a triangle or by a trapezium, or even let it be any type of varying load, distributed load. Even if non-uniform distribution also will do. You should know one thing. There is a term called loaded length. But I always insist, loaded length considered. That I told so many times, I will explain later. Then, one should decide the loaded length consider, only that much length you have to consider. Okay. Then, distributed load, I told. We want, see, your hand should move like this. In case of distributed load, we always define it by intensity. Intensity is the load per unit length. If it is UDL, intensity is constant. If it is UVL, intensity will vary. Whatever it is, we define by intensity. Example, W per unit length or numerically kilonewton per meter. This all I told earlier. Now, kilonewton per meter is load for 1 meter. But we want load for entire loaded length. Therefore, when you consider the entire loaded length, we want, see the hand, magnitude of total load. When you tell magnitude of the total load, your hand has to move like this, like a point load. Make a note. That is given by area of the loading diagram representing the load, and line of action of that total load will pass through centroid of the loading diagram for loaded length considered. That I told. Now I will not tell people who have no patience to go through, who are not but keen to observe each and everything. If they get a problem later, it is their problem. Okay, now this is over. Now I will tell you what I am doing today. See, now when I started type of loads, part 1, point load already over. See, I wrote part 1, type of loads, concentrated loads. Then, this is your lecture number, I don't know. Okay, leave it, surrogate. Now, I will tell it next time. After this class, part 1, in between, we are doing class number what? Yes, see, lecture number 22, 23, I think 21, 22, 23 are all discussions. Our part 1 stopped there. Now there, little later you can see, I will tell later, all these are explanations. So what we have to cover is types of loads, part 1, point load, everything over. How to find load, how to locate line of action, and then how to find moment also over there. Part 2 will be UDL. Part 3 will be UVL. Part UVL by a triangle. Part 4 will be UVL represented by a trapezium. But before I start these three, I am giving lot of explanation because all these comes under distributed load. Already 2 or 3 classes are conducted after that part 1. Part 2 is still waiting. Part 2 is systematic way of examples will be there where moment also will be considered. Now, final explanation. Okay, all this you have to remember now. You first of all go through each and everything, then there is no confusion. So this part 2, part 3, part 4 is not our subject point of this part 2 is equilibrium. See, in the thumbnail you can see this part 2. This I write in the description. Okay. Now I will lab it and go for distributed load. What is that final explanation I will tell now. First, UDL. Uniformly distributed load, UDL. See, technically this is correct. This is the perfect one. As I told earlier, you should write a note. I will dictate in the class. L0 is loaded length considered. We want that L0. Who knows? The UDL may go further length. We are not bothered. Somebody wants for this much length. Okay. You consider L0 is loaded length considered. Repeatedly I am telling. Now, uniformly distributed load is defined by intensity, say, and intensity is constant throughout the length, uniform, W per unit length. Don't tell W kilonewton per meter like that. Okay, now, close arrow mark. If you want, you can put further close arrow mark. Don't count the number of arrow marks. Sometime, I will ask in the class, 1, 2, 3, 4, how much? Some will laugh. Sir, it is a representation. Okay. Now, remember, load is represented by a rectangle. Rectangle. Now, what we want now, what all I am telling, I am dictating. You should write seeing the class. I will use red color. We want magnitude of total load. Yes. And already I told you, magnitude of the total load will pass through centroid of the loaded length considered, that is here. See, this is magnitude of total load for loaded length considered. See how much I am writing. Loaded length considered, that is L0 length. Okay. Now, I told repeatedly, intensity is not the magnitude, it is intensity. So, when you tell magnitude, now onwards, your hand should move like this, but you should not write it. Imagination, see, total load. How much? I told 1000 times for you, equal to area of load diagram. Area of load diagram. Load diagram, once again, for loaded length considered, you should write equal to base is L0 and height is W. Is the answer. This I told last time. Last time rectangle I told. And the result, that load will pass from here at L0 by 2, from here also L0 by 2. This is technically correct. See, correct. Now, one note you have to write. Note. Very powerful note. You should write. Actually, from now onwards, for UDL, we will not do like this. Because, of course, see, same will be used for UVL. UVL means either triangular representation or trapezoidal. But UDL, now onwards, we will not do this way. What we will do is, see here, we will write the UDL like this. But write W per unit length. It is, W is the intensity, that is load per unit length. Loaded length is L naught. We will do some other way. Here see, base is L naught, height is W. Area I told, base into height. But here what we will do is, see, total load. Magnitude of total load for loaded length considered of L naught equal to, see here, what you will do. W is the load per unit length. I'll give simple, like I told already, 1 meter of a cloth, some maybe shirt piece, shirt material, or any cloth, 1 meter will cost you 200 rupees. We want to buy 5 meter. Here, this is cost for 1 meter, W per unit length. L naught is the loaded length considered, how much length you are buying. So, if 1 meter length will cost you 200 rupees, 5 meter length you have to pay 200 rupees into 5 equal to 1000 rupees. See, 200 is the 200 rupees per meter, but 1000 rupees is total, like a point load. So, equal to W into L naught. Once again, same, see, interchange. Here, base into height, here, height into base. But height you have to imagine. We are not, see, actually, that means this height is W. Or, this I will tell once again later, in case of UDL, we will not bother about area. You can consider area, no problem, but no, waste of time. So, make a note, big note. Make a big note. In case of UDL, in now onwards, we will not bother about that area. Simply, total load equal to intensity into loaded length. That is what? How you got it? That is intensity of load, intensity of UDL into loaded length considered. Loaded length considered. Over. Now, where it is acting? From here, center. This L naught means L naught by 2 and L naught by 2. Now, I will tell goodbye to UDL. Further will come in the example. That's why I told final explanation. Now, uniformly varying load, UVL, represented by a triangle. 3 subdivisions here. Subdivision 1, UVL represented by a right angle triangle. Either, see, AB. See, this AB is not one AB, distance will come later. Don't think that this is numbering, AB. If you want, write. Here, left side 0 intensity increases to maximum at right end. See, close arrow mark your right. This way. Okay. You put these 2 sketches. Don't touch this one now. Right. Consider, again remember, this is L naught, loaded length considered. Start. A. This one. I told thousands of times, we want total load. See, where it is not center. Centroid will shift this side. This all I explained for you. This is centroid. I won't write centroid now. Those who want, write it. Centroid. You write it, centroid. So, see the arrow mark here. See here. Yes, this is magnitude of total load, again and again writing for loaded length considered. How many times I am writing, see, loaded length considered, that is L0 length. Okay. Now, how to get it? Equal to, I told repeatedly is given by what I told, equal to area of diagram, I hope it's not out of the camera, area of the diagram, yes, within the camera. Now see, I told UDL short form, UVL area you are using, area of the diagram representing the load, not writing proper permission, see, area of diagram representing the load for loaded length considered, area considered, that is L0 length, area of that length L0. So you can write here equal to half into base L0 into height is W. So I will always use a bracket here in future. For UDL also I forgot last time. I will use a bracket. I forgot right. Last time, see, use a bracket there. Okay. This is total load. From here, thoroughly explained, 2/3 of L0. From here, 1/3 of L0. Now, you know load. Now, if you want moment, see, load into distance. Okay. This is for A. I will change over to B now. I'll save the type here. I'll change over to B now. B. See, I'll save the time here. B. You should write once again. Don't make it this way. B. W per unit length. Here. See. Okay. See. Same writing. Magnitude of the total load for loaded length considered L0 equal to area of the diagram equal to half into L0 into W. But this time from here 1/3 of L0 and from there 2/3 of L0. Someone will ask, sir, not clear. Don't. If not clear, don't continue my class. Leave it. My class is not for you. After so much explaining earlier, now if you tell why 1/3, 2/3 means not fit for structural engineering education. Okay, this is also over. UVL represented by right angle triangle over. Now I'll do one thing now. I'll rub and make other one. See, adjustment here. So that no pausing required. See, 2. UVL represented by an isosceles triangle. That is, see, this is a W per unit length. This is your L0, that is loaded length considered. Red color I am not using now. Loaded length considered. Full length considered. And remember, each of these distances are equal. See, isosceles means this side equal this side or this side equal this side. If this is L0, this is L0 by 2, L0 by 2. Okay. Now, come here. I am adjusting this one. See, this is to save the time. I don't have to write again and again. Same place. Hope it is correct. Okay. Such things don't bother. It has not come properly. Okay, no problem. This is loaded length, consider L0. This is W per unit length, the maximum intensity. We want total load will pass through for full, see, we want total load for full diagram, right here, for full diagram. I told L0, centroid will be here. Magnitude of the total load for loaded length considered L0 given by the area, once again half into L0 into W, but line of action will be L0 by 2, no 1/3, 2/3. Why? Because it's not right angle triangle. It is a symmetrical triangle, so midpoint L0 by 2, L0 by 2. This is for UVL represented by an isosceles triangle. Now I will go for 3. 3. 3, I think I want more space. Therefore, this I will remove. This I will remove now. 3 I will remove because I want more space. This all I will remove. Okay, that will be okay. For some time it will be there. Okay, no problem. See, sometime it will be there. 3. UVL represented by a triangle in general. In general, it need not be what? Isosceles. See, that is, two cases are there. Case A, this if I put A, B means problem now, I will put here 1 dot. This way. Or 2 dot. Same I will put here now, see. This way. If I project light line here, this is maximum W per unit length. This also is W per unit length. For both of them common, see, for both of them common, I will write here now, common for both, right here. This is L0. Loaded length considered. Loaded length considered. But here, this cut distance, I will take A. This A is not, this I will take B. This I will take A. Left side I will take A. Right side B. If A become equal to B, it will once again become isosceles triangle. Once again it will become center only. Okay. Now, very clearly I have to explain. See, now, 1. Again I will use the same space to save the time. This is advantage for, see, you should not do this way. Or right here, this is the case when your B is here, your B is more than A, and this is the case when A is more than B. You should write. So I am taking the case when A is lesser, B is more. See, now some space problem is there. Okay, I will cut here. This is A, this is B. Okay, sufficient. This is W per unit length. Unit length. Okay, now we want total load. Magnitude of total load is equal to, once again, area of the diagram representing the load equal to half into L0 into W, remains same. But the line of action will pass to centroid. See, here, this is bigger. You can see here more area. So centroid will be somewhere here. This all I explained last time. So this is where the resultant load will pass. Now I should write where. This is your magnitude. Okay, I'll do one thing to save the time. Okay. Yes, see, now matching. I will do one thing now. Here I will write A, B, C. I will write A and B here. This is to save the time. Out of scale. This is your A. This is your B. Okay, now, little tilted, adjust it. Total load. I told you, if you want distance from here, it is full length, L naught. Last time I told base, full length L naught plus this cut length A divided by 3. If I want from here, full length L naught plus cut length B divided by 3. This all explained last time. Now, make a note. For those who find difficulty to remember this formula, there is an alternative. Alternative is, I'll tell you, this one and this one consider separately. Then one load here, one load here. Then it becomes two right angle triangles. This I will discuss when I go for our type of load part 2, part 3, part 4 with all examples. Then I will tell. Right now, sufficient. Okay, now UVL represented by a triangle in general over A case over. Go to B case. Same way, B case. Okay, this is one, not B case, two, second case, 2 dot. 2 dot is, see, you should not do this way. You should write once again. Remember, don't play this way. This way, okay. It is this way and this way. W per unit length. Unit length. This full length is L naught. Now AB changes here. One nimisha, see. This is the change point. I will dotted line will put here. Okay, I'll bring here. See, from here to here is A. From here to here is B. I forgot last time. I forgot here. See, last time when you put 1 dot, you write B more than A. Last time you write it here. Now you write 2 dot A more than B. Now also load, these all will remain same. See, total load area half into L naught into W. But one thing, centroid, this side more area is there. Centroid will be here. So your total load will be, see, here. Now right here, magnitude, see, match it. Magnitude of the total load. Now whether A more than B or B more than A, I told you last time, go once again, formula remains same, not L plus, L naught plus A by 3. Oh, just now I don't know what I wrote. By mistake, if I put L plus A by 3, by mistake, I don't know. See, sometimes what happens is, I take span as L. See, it is L naught plus A by 3. This is L naught plus B by 3. In the previous case, by chance, if I wrote L plus A by 3 and L plus B by 3, you change it to L naught plus A by 3, L naught plus B by 3. That much you should do it. Okay. This also over. Now fourth case is uniformly varying load represented by a trapezium. I will explain that one. With that one, everything is over. Then you go for a systematic way of each load in different parts. How to find load already over with a numerical example also. And also how to find moment will come there. Closing part is pending now. Now, concluding part, uniformly vary. What is this one? I don't know. It is already 2 a.m. in the morning. See, feeling slightly sleepy. Uniformly varying load. Okay. Because what happens is sometimes I thought I am writing UDL, uniformly varying load represented by a trapezium. Okay, see. this way or this way. Here, left side minimum intensity, right side maximum intensity. Here, left side maximum, right side minimum. Which is minimum, which is maximum does not matter. Left side is W1, right side is W2, and this is for loaded length L0. See, loaded length considered, loaded length considered, loaded length considered, loaded length considered. Who will have this much patience, tell me? This clearly shows how much, see, I am even losing my voice because of marathon class earlier. This is today's, I had a long class earlier. That's why late night I am doing it. So, loaded length considered. For that length, this is a variation. Okay, start. A, W1 per unit length, W2 per unit length. I told you first you require total load. For this loaded length considered, right here, is given by area of diagram representing the load for loaded length considered equal to L0 equal to, I told you, sum of the two parallel sides divided by 2, divided by always 2 into distance between the two parallel sides, that is your L0. Very powerful L0. Okay. Use a bracket. This complete bracket will give you total load. From here, you require, it will pass through centroid of this loaded length diagram. For L0 length, where is centroid? You should write it. This is centroid for L0 length. I told you formula, if you want from here, last time explained so thoroughly, this side W1 plus twice of that side divided by sum of the two sides. Let's see, yesterday I told you H1, H2, now loading W2 into distance between the two sides L0 divided by 3. Now, here, into L0 divided by 3. I'll tell you why I put that way. Here, if you want from here, this side first, W2 plus twice of W1 divided by W2 plus W1 into L0 divided by 3. It's one. Now, you can make a note. Those who find difficulty, see, area there is no problem. Sum of the two parallel sides divided by 2 into distance between them. But this confusion, for them I will give a remedy. What you can do is, see, you can replace this one by a rectangle and a right angle triangle. That is one UDL and one UVL represented by a triangle. Here UDL constant, UVL maximum this side. This will be your W2 minus W1. This all I will explain when I go to part 2, part 3, part 4. Okay. 1 over now. Now B. To save the time, B. In case of B, what happened? W1 is bigger, W2 smaller. I should save, see. This is my advantage of using the space. Okay. This way. This is W2 per unit length. Now, CG will slightly shift this side. And that's why I wrote here, see. It will be this side. This is the total load. Okay. Yes. That's all. That's all. See. Total load equal to area W1 plus W2 by 2 into L0. And centroid from here, distance will remain same. Last time CG was shifting that side. Now slightly this side. Okay, this is bigger, this smaller. Out of scale. Okay. This is for uniformly varying load represented by a trapezium, or later what you can do is, those who find difficulty, see, they can now divide like this. See here. This way. They will get a UDL and UVL. This time, this side maximum. It will be W1 minus W2. This all I will explain when I go to part 2, part 3, part 4. Okay, now one very important information. Make a note. Types of loads. See, our types of loads. Initially I told introduction. Then part 1 is for concentrated load, where I tell complete one's W type and numerical also, including moment. It is already over. Now, part 2, part 3, part 4 are coming up. Part 2 is for UDL, this is for triangle load, this is for trapezium. Here I will consider moment. So, but after that point load part 1, till today, what all I told is preparation for distributed load, or getting more and more grip on, so that when you go to this part 2, part 3, part 4, absolutely there is no difficulty. And I will tell at that time, if not clear, do not attend, do not go through my class. Not fit for education. You show me one person in the world who has got this much, this much patience, so much loaded length considered. See how many times I wrote. Why? Because I want perfection. And as I told, I teach in a simple way, not go for complication. Complication I can go, but not going. Because purpose is to educate in a simple way, but effective way, so that maximum knowledge comes. After part 1 till today's class, everything you make a note outside separately. Get ready for next class, part 2, part 3, part 4. One exclusive for UDL, where moment also will be there. Then UVL by a triangle, and lastly trapezium. Okay, thank you. See you in the next class.